TDWI webinar program. I'm Andrew Miller, and I'll be your moderator. For today's program, we're going to have a fireside chat on baselining the state of spatial data science. Our sponsor today is CARTO. For our presentations today, we'll hear first from James Kobielus with TDWI, and then we'll be joined by Matt Forrest with CARTO and Philip Cooper with AWS for a fireside chat. Before I turn over the time to our speakers, I'd like to go over a few basics with everybody. Today's webinar will be about 40 minutes long, and at the end of their conversation, our speakers will host a brief question and answer period. So if at any time during these presentations you'd like to submit a question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, you can click on the Help area located below the slide window, and you'll receive technical assistance. If you'd like to discuss this webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweets. And if you'd like a copy of today's presentation, please locate the resource window to download the PDF. Lastly, we are recording today's event and we'll be emailing you a link to an archived version so you can view the presentation again later if you choose, or if you'd like to share it with a colleague. Again, today we're going to be discussing the baseline of the state of spatial data science, and our first speaker is James Kobielus. He is the Senior Director of Research for Data Management at TDWI. Jim is a veteran thought leader, industry analyst, consultant, author, and speaker on analytics and data management. Over the past 3 decades, Jim has held analyst positions at Futurum Research, Wikibon, Forrester Research, Current Analysis, and the Bergen Group. He also served as a Senior Program Director for Product Marketing for Big Data Analytics for IBM, where he was both a subject matter expert and a strategist on thought leadership and content marketing programs targeted at the data science community. At TDWI, Jim focuses on data management, which encompasses database platforms, data governance, data integration, master data management, data ops pipelines, and more. Welcome, Jim, and I will hand it over to you now.
Thank you, Andrew. Hello, everybody. I hope you're having a good day. So before we get into the fireside chat, just a quick context setting slide here. It's all about baselining spatial data science in the enterprise. Spatial data science, what's it all about? Well, it's a set of practices for extracting useful insights from location data. In other words, data on what's happening where, what has happened where, and what is likely to happen in the future where. So using machine learning, predictive models, really other analytical algorithms and models in this effort. And spatial data scientists are the people who do this. So with that said, I'm going to hand it back to Andrew to introduce my 2 panelists.
Perfect. Yeah, now it's my pleasure to introduce our guest speakers. First up is Matt Forrest with CARTO. Matt Forrest is the VP of Spatial Data Science at CARTO and is passionate about using and sharing ideas around modern GIS, helping others to use a variety of new tools in their geospatial workflows. Matthew graduated from the University of Wisconsin-Madison with a degree in geography and has been working with GIS and in geospatial for 11 years, with the past 7 at CARTO. Our next speaker today is Philip Cooper with AWS. Phil is an established business and technical professional in the technology sector supporting growth and use of satellite, space, and cloud technology. He has worked in large aerospace industry at Airbus and went on to build Earth observation and geospatial business Sterling Geo over 8 years. Today, Phil is the Geospatial Global Leader for the Aerospace and Satellite Division of AWS for EMEA and supports their geospatial customers globally, building on the cloud across the space domain. With Earth observation and geospatial data creation accelerating for new customers and partners, Phil brings an understanding of what AWS has to offer in the geospatial community. Welcome to both Matthew and Phil. And with that, Jim, I'll hand it back to you for the conversation.
Thank you, Andrew. Hello, Matt and Phil. Great to have you on the panel. So we'll just roll with it. First question we have is, what are the principal use cases of spatial data science in the enterprise? And really, this is for both of you. Whoever wants to jump in first, go for it.
I can take a stab at that. I think that for me, I think there's a few different ways to use this, and it's hard to sum up exactly how many there are within different industries, and that's sort of the tricky part, right? Because every industry, in effect, can make use of location data. The key is first of all identifying what type of location data you have or need, right? If you have an address or latitude and longitude or even a state or a city, That's location data, and you can use it in different ways. And then the second part is, what do you need? Of course, there's lots of data being generated from imagery, outputs from that imagery and analysis. There's data that's being generated from third parties, OpenStreetMap. So there's lots of different ways to use that. But I think there's, if you want to sum it up in terms of the evolution of spatial data in the enterprise, I think there's first the ability to pick those data sets, find and do a sort of a cataloging effort of what data you do have and how to use it. Second is understanding the infrastructure that you need to actually make use of that data. Geospatial data, in and of itself is different from regular data in that it takes up more space. It is a little bit more, computationally complex to process. So you need to understand if, what type of infrastructure you're going to need. And then ultimately, there you go from the understanding or the sort of, ESDA or the exploratory spatial data analysis kind of process to understand what's happening. So that's the first step, is to see what's happening, where, and then of course with location you want to see where that's happening. And then I would take that a step further to use that to understand how or why something's happening into that predictive mode. So that's a really high level explanation, but a good example of that might be, let's take a logistics use case, right? We are a logistics company. We know we have a fleet of moving vehicles that's moving around all the time. And we want to understand the impact of, let's say, weather or climate on our fleet, and then optimize better around that. Of course, we'll need some weather data. We'll need an ability to process all that, sort of the trajectories and moving and latitude and longitude of that data. And then once we have all that, we can see what the patterns are, if storms are slowing down our fleet, where those storms are taking place, and then move into some sort of predictive use case. If we can understand where weather may or may not be happening, can we modify, can we make adjustments, and can we create some sort of predictive tools to go through that? And that's all kind of tied into this whole use case of spatial data science, right? Is that getting to that predictive state.
Great, Matt. So Phil, your thoughts?
Yeah. I mean, I think probably from my point of view, it's change detection. It always has been change detection. I think from the moment that I'm an Earth observation scientist by trade, and right from when Apollo 8 first took that photograph of the Earth rise over the moon, that was a fascinating image. But as a remote sensor, I was always looking for the next image. And how do we see change detection? And that change detection, which is happening at an accelerated rate, is reflected in remote sensing data. It's reflected in survey data. It's reflected in tracking ships. And actually, as humans, we like to understand change. And the challenging in spatial data science is the volume of that data that's now coming in is how do we deal with that accelerated change that's taking place on Earth? And so I'd say change. It really is as simple as that. And the tools that we need to do that, that's the bit that we're working so hard on at the moment. That would be my initial thought.
Very good. We'll roll to the next question. So what kinds of insights should spatial data scientists be extracting from enterprise data? What kinds of insights? For what use?
So I'll have a quick crack at that, sort of following on from that change piece, and then Matt can obviously go into the details. But I think we talk about geofusion, fusion of data sets. Just understanding that one piece of data on its own doesn't really have any effect unless we put another piece of data on top of it. And spatial data, when we talk about power lines and trees, whether we talk about mobile phone towers and road networks, whether we talk about ships and oceans, it's only when you bring these data sets together and we start interoperabilities. It's a great term that everybody uses, but really it's geography that ties these data sets together. And that's when the insights really come to bear. And so I'd say that interoperability, geospatial data fusion, raster and vector living together, and actually deciphering from that what trends are taking place. And Matthew was talking about insights and analytics. And that only really truly comes when you start looking at, well, how has this piece of data changed over time? And actually, how is the data over the top of it? And at this moment in time, the sources of this geospatial data are expanding at an exponential rate because they're coming from not only what I would call standard structured environments, aerial photography, satellite imagery, GPS, but also unstructured environment as well, social media, IoT. And I think that's probably really where we're extracting the most intelligence. Matt, what would you think to that particular point? Because what CARTO do is obviously so much more in depth.
Yeah, no, I mean, I totally agree. It's, Just the fact that we can have and blend raster data and imagery and build more and more, kind of interpretive models from raster data faster and better than ever before is just that in and of itself is pretty groundbreaking and fortunate with the the challenges we're facing today, understanding critical issues like climate change and impact on infrastructure and all these different things, right? It's a good time to have that be taking place. And I like your point about interoperability because I think historically, geo's been kind of segmented into its own little, kind of corner, right? We're all geo, but we don't kind of interact and interplay with the broader analytics space, which I think is unfortunate because I think there's great minds on both sides. Having people that understand geo, but having the ability to not just talk to individuals from that side, but actually write work on problems together. I mean, and on a base level, write code together, right? That's something that didn't always exist, and now I think we're breaking into that. We're sharing infrastructures, we're sharing languages, we're sharing machine learning libraries. I mean, everything's getting in that same sort of use case. So when we say what sort of insights should come from that, it's kind of the same problems we want to understand. In a broader data science context, we want to predict, we want to forecast. We want to sort of understand, label data, right? All the same type of things. How can we, and I think that the really good question is, like you said, how can we bring those two together to say, what are those critical business problems where location can play a factor and just accelerate our understanding of that and breaking down those barriers is really key. So it's kind of, it's hard to, like I said, there's so many ways you could dive deep on specific problems, but that's where I would go with that answer.
Very good. And you mentioned shared libraries and platforms. That segues nicely into the next question, which is, what are the core tools, libraries, and platforms required by today's spatial data scientists? Matt, keep rolling with this, or you can hand it to Phil, or you guys decide.
Okay, Matt.
Yeah, so this is one thing that I've kind of started to talk about and write about more is understanding some of these core pieces of the puzzle, right? And especially as data is growing at such a fast rate, what do you need? So I'll get pragmatically into it. I think that there's a underpinning of tools that sort of exist in the geospatial space, that are commonly used. In terms of languages, I would say SQL, Python are definitely moving at quite a bit. And then there's the infrastructure that supports those within cloud environments and other places. So that whether that be a cloud data warehouse or the ability to run machine learning workflows in the cloud, tools like, in the Spark ecosystem and things like that to do, processing, I think are all pretty critical. Libraries, there's kind of the underpinning core of things like GDAL, Geos, some of these base libraries that can process spatial data really effectively. And then on top of that, you start to build different components, whether that be, on a very base level, Postgres, PostGIS. A lot of those same spatial SQL functions now find themselves in data warehouses that have that, that scaled compute and storage separation to make things run really fast. Within some of the machine learning libraries, you can certainly use and borrow from the broader data science world to apply that to interpreting and analyzing and building models on top of raster data. In terms of the pure spatial data science libraries, I always say that PySal, or the Python Spatial Analysis Library, is one of the best in terms of core use cases, specifically on vector data. It just is, some of the best thinkers around that. So I would always advocate for checking that out. There's spatial indexes like H3s and things like that. And some of the work we've done at CARTO is how do we take all of that and put that into the infrastructure that can really help that scale. And that's what we've done with our analytics toolbox, is sort of taking those best in class, well tried and true and open methods and bring them in to really just, if you want to run that on a ton of different data, you can. So that's where I would start. I mean, I could talk for hours about this.
No, that's great. That's great, Matt. And I think just sort of to take the baton on a little bit, one of the things that we focus on is cloud native solutions now with so much data. And actually where we've got tools like Lambda for event-driven architecture or machine learning modules using ECS and EKS. But within that, we've paid real close attention to things like languages like R and PyTorch as well, and Spark ML, which you've mentioned, or TensorFlow or Apache Spark, which we've made sure that we support in things like SageMaker. So we've taken that on board, and so much of the services that we build in AWS is based on what customers asked us for. But I'm going to take that a little bit further and actually going to reference, I think, some of the project work. I know the CARTO with things like Geoparquet, and actually having the projects such as Geoparquet, which allows cloud to accelerate innovation, and that innovation which is coming from the open source community. I mean, so much of what you've referenced there is from the open source community. And so I think the more that we can listen to that, make those tools available, run them on our services, then not only do you take advantage of the tools, and then what we also do, just to give a little bit more plug to the data as well, is we have the open data platform as well. So that data is available, making those things faster, innovate faster, but also I think it's critical to anybody developing these tools that they can fail fast as well. So build the solutions, build the things, test the outcome, and then see the outcome, but also move on quickly. And so very much in agreement with the tools. As I say, I'd be a big plug for Geoparquet again, as a program and a project which continues to support. And then really, as data scientists, being more comfortable, which is bringing code to the data and working with the object store and events-based mechanisms, which enables them to actually work with architectures in the process. Like, for example, as we're seeing more and more HPC workloads as well. So because geospatial data is now actually taking advantage of HPC. 23 years ago when I started, I'm not sure that there was enough data to take advantage of that. We are actually in an amazing situation today when we can, and so therefore we can start experimenting with those toolkits. That will be definitely the sort of thing that I'd advocate for.
Good. Well, shifting the focus from tools and platforms to people and skills, what are the essential skills, training, and certifications to be an enterprise spatial data scientist?
I mean, I'll take the first part of that, Matt, and then sort of hand across to you if that's okay. But I think certainly one of the things which is important is certainly from our stages, things like cloud certification. I mean, just because there is, we have over 200 services available, but we also have certified machine learning specialists and data analytics specialists. But I think spatial data scientists that can take advantage of the tools and the programs that are already available in the open source community, have a good, strong understanding of GDAL, but also take advantage of Python. Python is just an incredibly helpful glue set. So if you're not a programming specialist, and I would absolutely count myself among those skills, but actually understanding Python, joining code together, but at the same time recognizing that the open source community takes the recognition for that, because there are so many out there, so many good programmers committing code and committing things to GitHub, but actually where Python becomes invaluable, understanding how to link these tools together means you can bring out your own services and actually move forward faster. So I'd always advocate for cloud certification, because actually that's the resources that are available to you, but then really dig into the community and pull from that. Matthew, I'm not sure what you'd add on to that.
Yeah, I think that's a great, a great place to go. I think those are, I definitely advocate for kind of a core stack, especially if you're just starting out. And for context, my background is in geography, right? I learned geography and what you would, call GIS on, desktop software, right? I frankly, I learned ActionScript as my programming language in Flash to make interactive maps. So a lot of this was, kind of trial and error over the course of my career to kind of get to where I was, especially in this open source side, which I think has now become more a core part of the education. But if you want to learn, and you're I would first start with, if you're just starting out, QGIS is a great place to start, right? It has great pieces set in. You're not going to be able to scale to massive data volumes, but it has those core libraries built in. It has GDAL, it has the ability to connect to PostGIS, and that is where I would lead into the next kind of languages and skills, going from SQL, learning Python, investing time in terms of understanding those tools, and then the underlying libraries, right? That can process spatial data, analyze spatial data, and do all those things. Now, those are all things you can do right now today. And then to take that into enterprise, it's definitely some of those cloud components, right? The same languages and the same things you're running, on your computer, you can immediately port into, a system like AWS. If I'm writing an ST intersect on PostGIS, I can immediately do that with way larger data in Redshift and go from there. If I'm writing something in Python, I can scale that up with infrastructure in AWS. So there's a very easy way to say, okay, I've done this here, and how do I go there? And there's, of course, certifications and things that you can process and add to your kind of toolkit from that perspective. So there's that core language piece, there's the core libraries and understanding how they interplay together, and then you just kind of basically accelerate that by moving into a cloud infrastructure. So those are that's where I would start, and then get those trainings and build from there.
Very good. So rolling with this, staying on the topic of basically human resources, spatial data scientists, how should spatial data scientists, be using AI, deep learning, and machine learning tools in their work? Not just building and training these models, but how should they use these tools to augment their productivity as spatial data scientists? Who wants to jump in with this one?
Yeah, I can give it a shot. I'll pick this apart in terms of 3 categories, right? There's the machine learning, right, which is one group. The second is I'll talk about some of the deep learning pieces and how you use those, and then more broadly, how do we discuss AI and some of the LLMs and these massive things that are taking place. So the first is machine learning, right? You're using some data to predict points on other data, whether that be, does it fall in a cluster? Does it, can you predict a value or anything like that? There are great machine learning libraries out there that you should be using, whether that be simple linear regression from scikit-learn or things like, XGBoost or CatBoost or whatever, regression boosting library that you want to use. Geospatial data just becomes another feature within those libraries, right? And it's using your geographic knowledge to understand what may or may not be important, providing that as a data point to that model, and then learning how to use those models, right? That's a very easy step you can take, and a lot of that's in Python already, or there are, if you want to scale that up and you said move the code closer to the data, of course, things like Redshift have machine learning that's already there, and it's, it's built by great engineers, so it's going to be good, right? So you can move that closer to the data. So that's the pure machine learning side. I think that's the easiest place to start. From a deep learning side, that can be, building, deep learning with, whether that be TensorFlow or, PyTorch or whatever you want to. Specifically, I think that's the best place to do that is analyzing and segmenting imagery, right? Using imagery to create and understand what's happening there. There's a lot of different things you can use to do that. I mean, and there's so many use cases there, from understanding erosion or land cover or what have you, right? There's just, and Phil, this is kind of your space that really, really well, right? I'll leave you to comment on that one a little bit more. But the last one is on those, like, on the, things like, all the LLMs that are coming out and GPT and things like that. It's still kind of TBD, right? I frankly, I think it's a great place to, if you're just starting out, understand and ask questions and maybe get a little bit of sample code that you can help you kind of, work your way through, some of these early stages as you're learning, right? Helping you debug and things like that. I have yet to see where all this plays out. There's some theories that we might be asking these LLMs geospatial questions and they're turning things back to us. There's a whole open world right now. I think right now what I've been hearing is using it in very practical ways to make your work faster is the best way to do that. And that's like as of today. In the future, who knows? But that's where I'm thinking right now.
Yeah. And I think, everything's about speed as well. I think, but also I think there's efficiency. I mean, a lot of the time when we talk to our customers, we start with be efficient with your data storage at the start. Spatial data, machine learning and deep learning relies on the data. But I think even there's a step before that is checking the quality and the advocacy of the data. And I think that this is a big opportunity for the sector to make sure that, so a lot of what we do with S3 or Redshift, which we've mentioned a few times, is, preparing the data, segmenting the data, get it ready, fit for purpose, so that when you do run your machine learning algorithms, it's already been checked, and make sure that the analysis that comes out makes sense. I think sometimes it's very easy to do, and analytics is an area that I've spent some time in looking at different type of analytic tools and outcomes, but make sure it makes sense, and also use your sort of human. Machines haven't taken over yet. Don't worry, our human instinct is still. Well, actually, I'm not sure that makes sense. Let's use some checks and balances in this data processing. And the sort of things that we're doing at the moment, especially with machine learning, with things like SageMaker, is to prepare the data, train the modules, but also take advantage of compute to run EC2 instances and EKS instances to run the processing efficiently. The other question to ask yourself is, do I need to have multiple copies of the same data set? And too often data sets can be duplicated when they don't necessarily need to be. So starting with those basics of S3, I will always come back to S3, the authoritative data stores for geospatial data, preparing the data, indexing data, things like stack index, etc. But then we start getting advantage of TensorFlow. I'm actually a big fan of random forest as well, which I think is an extremely powerful capability for remote sensing, particularly, once again, the EO person here is processing data using random forest is exceptionally good. But one of the things as well with SageMaker, with what we try to do, is make sure that you can run TensorFlow or PyTorch on those environments. And so that is always important. And something that we're always striving to do. And the key thing is, it is getting there's more of it about, and I think that's a good thing, because we can corroborate data. Just because one piece of intelligence tells you one particular fact based on the geospatial location, the advantage with more satellites in orbit and more data feeds is we can corroborate data and back it up and evidence that. And I think, and although we're not going to touch on it today very much, is carbon sink and carbon sequestration is now a huge topic. Being able to back up the evidence of carbon sinking is with satellite data and geospatial data is going to become a huge topic, and I think machine learning is going to have a massive part to play there as well. So I see that all happening, but prepare the data, check the data, and then absolutely these machine learning algorithms and AI becomes incredibly valuable, I think would be
very good. So in the interest of time, moving on, clearly spatial data scientists are highly skilled individuals and they're using sophisticated tools, but it's a very human practice. So what are the most challenging aspects of their tasks of acquiring, modeling, and analyzing geospatial data? What's most challenging about this kind of work?
I'll start that one. I'll let Matt pick up the second half. Challenging. I think I was eking into it for my first question there, which is data preparation. And if there's one message you can take away, is please prepare the data, check the data. Data standardization, sometimes lack of data standardization, is a massive challenge. And I think that it's really important within this industry, and anybody who works with spatial data is you've got to make sure that you trust and have validated the data that you start with. So data prep. It's top of my list. And then with machine learning, you can chunk the data up and then rejoin it up again then later after inference. Data quality. How good is the accuracy of the data? Having spent many years doing survey work as well, data accuracy was critical. Learning the difference between absolute accuracy and relative accuracy. Sometimes that can make a huge difference to the data outcome. So I think that's really important. And obviously with machine learning, the higher resolution, the better. And I think that's something, higher resolution does indeed bring more detail, but of course, it's more processing. So always balance data quality against how cost effective it is. Sometimes you don't need the most accurate of data. Sometimes trend analysis, we look at things like field analysis and change detection as we do with our customers. Actually, it doesn't need to be the highest resolution. So there's a real balance here, unfortunately, and I can't get the answers between quality, resolution, and accuracy, and that will ultimately start with what's the use case. And we have a process in AWS called working backwards from our customers. And I think really, if I stress anything as well, is understand what your customer needs to do, what they need to achieve, and then working backwards from that, those decisions start to come out. How fast does it need to be there? How accurate does it need to be there? And what trend or change trend are we looking to analyze? And so that's, once again, where cloud can help, because you can run these experiments quickly and cost effectively. But those are the things, and data preparation, absolutely top of my list. Matthew.
Yeah, there's the classic ones, of course, projections, managing, different projections and units of measurement. There's formats, GDAL, I think, has it's close to 200 different formats that it supports. I mean, in the general analytics world, you have CSV, Marquet, lots of formats, but geospatial, I think, takes the cake there. In terms of analyzing, it's understanding a lot of different problems about geospatial data, such as geospatial support, right? How do different layers go together? Are you measuring the right problem at the right level? I've written about the practical implications of using zip codes as a spatial measurement, which it for a lot of use cases doesn't have real implications, but there are use cases. I mean, the Flint water crisis was basically predicated on the fact that they were measuring the issues at a zip code level, which had parts of Flint in them, but also parts of the rural, which made the problem look a lot less worse than it actually was, right? So there's actual real world implications to the level of spatial support that you use. The two things that I think that, on acquiring, I will touch on that point because I think, there's lots of data providers out there, there's lots of places to get data, tools like, some of the data, Amazon Data Exchange, ADX has a really great way to find and acquire data sets and put it in one single format, which it takes a lot of headache. We do some of the similar stuff with the CARTO Data Observatory, so there's a place to get that. The biggest data problems I've had is processing. It's like, we were working with, telco propagation data, which, covered, 30-meter resolution across, a massive country. How do we take that, vectorize it, make it analyzable, do all these different things to it? There's a whole set of things that, especially when we get into these larger volumes, make it seemingly difficult. And then also, sort of those spatial support problems, like how do you move between different formats and things like that is really tricky. So there's the classic ones, and I think as we're getting into larger volumes, that's just going to expand and grow. And we've used the spatial indexes like H3 or quad bins to make that really effective. And especially in a modern data stack that allows you to do things like joins and aggregations much, much faster than you could before. So.
Okay, in the interest of time, I'm going to skip a few questions and move to this one. How should an enterprise approach migrating to a more modern geographic information system stack?
I would, yeah, I'll give it a whirl. So I think if you're in a kind of a traditional GIS system or things like that, the first way to look at that is your data infrastructure, right? If you're moving from a traditional server-based model where you have your data on a server and you're storing it in layers and things like that, start to understand what that would look like in a data warehouse model, right? If you're growing to a massive volume, separating some of the data that ties to geometries can be really effective there. And understanding what that means from a skill level perspective too. If you have people that are in charge of maintaining that infrastructure, now think of how we can transition some of those roles into maintaining a enterprise infrastructure. And once again, going back to those things like certifications and training and stuff like that, that can become really important. So that's the first place I was looking at. What is your data stack going to look like in a cloud environment? I think that's a really logical place to begin. And then on top of that, what are the outputs that you want to create from that? How do you even simple things like visualization, right? In a new world of data warehouses, that's the problem that we try to solve at CARTO is like, yes, you can process a ton of data, but how do you actually see it on a map? Of course, that was, there's different ways people were doing that, and you can do that, in notebooks and Python, but in an enterprise system, that's where we say, we do a lot of that. We've embedded tiling directly within a data warehouse to make the visualization really scalable, and then the spatial indexes to do some of those things too. So that's the approach that we're taking there. You have to start with where the data is going to live and how it's going to be structured and all those different things. And from there, once you're in the cloud, all these pieces connect really nicely from, running models in SageMaker, looking at imagery and then blending together, like you're in a great place there. So, these cloud, folks like AWS do this all the time. They take data from different sources, bring it to S3, so it's been done, right? So we know the playbook there, and that's a good place to start is data, of course. So.
Yeah, and just I think really just to sort of tap onto that is the future's serverless. so just like S3 from the start, really was a serverless environment. And now we talk about cloud native geospatial. We talk about being able to balance server and web applications with desktop tooling and knowing when each one has its place. I think is important. But absolutely, we're seeing and organizations who are architecting with things like Kubernetes and containerizing applications and services, because you've got to be flexible, and flexibility is going to be everything now. Where are those tools going to be running? Are they going to be running in the cloud? Are they going to be running potentially at the edge? We're seeing some really exciting progress at the moment, even with edge processing in orbit as well, with our one of our partners, D-Orbit and Unibap, actually running in orbit data processing now. So where these geospatial tools are going to run, got to think about that, and I think that's part of some of the thinking that's going through at the moment. But definitely go serverless.
Great. And one last question on this panel before we move to audience questions. What are the advantages, really, what is the chief advantage of bringing geospatial and broader analytics together into a more interoperable data stack? What's the chief advantage of doing so?
I think I'd go with that. Certainly, I think we talk a lot about geospatial data lakes as well, and I think as the environment's maturing now, that's fantastic. I think there's also this alignment of the geospatial data sets, the geospatial data lakes, the environment to store it in, and then the types of analytics that people are bringing from. I think we're seeing customers who are asking these new questions about analytics, not just in terms of business analytics, the here and the now, but also we're seeing a lot more about predictive analytics. So where are we going? And then ultimately prescriptive analytics. If we make a change at this particular point in time and space, what is the outcome? And I think as these questions coming back and they're understood by the geospatial science community, and that data says, well, actually, we have the intelligence, really understanding those questions means we can start driving those things. And the biggest thing that they do all the time is listen to the customers. What are the customers asking for? Because if we understand that we have a huge range of data, we have a huge range of technology, and actually we're starting to get specific analytics. Because as much as I love maps, and Matthew loves maps, I'm sure sometimes the customers do not want to see a map. They just want an answer. And I think that's probably a big change that we're seeing at the moment. Matthew, I'm not sure what how you'd comment on that.
No, I agree. I think the number one piece here to keep in mind is that, like I said before, geo has traditionally been treated as a separate practice, whether that's GIS, geospatial, whatever you want to call it, right? You have your geospatial GIS team, and then you have your rest of your analytics division, right? And that hasn't been just separated in terms of teams, but also technology. Bringing those two together, I think collaboration is always going to win out instead of keeping things apart. Bringing those together and getting more minds working on the same problems together and having that data, that infrastructure in the same place is really critical. And traditionally, I think geo has lagged a few years behind the rest of the broader technology and analytics space. Like data warehouses, the separation, compute, and storage data lakes have been talked about in analytics for a long time, and we're in 2023, and we're just now getting to that a little bit for the geospatial world, and that's starting to grab hold. So that kind of gives you an indication of that lag. The faster we get there together, the faster we can innovate, and the faster we can collaborate. That's I think the advantage.
Excellent, gentlemen. This has been very interesting. So I'm going to hand it back now. Close off. I'll hand it back to Andrew Miller. We have questions coming in from the audience. I want to give a little bit of time for those. So Andrew, take it away.
Yeah, thanks so much. That was a great conversation, everybody. We'll jump right in here. And Phil, this first question will be for you, but of course, Matthew, would love to hear your thoughts as well. So Phil, as the volume of spatial data continues to expand, what are the technology trends in response that you are seeing?
So I think the sort of things that we've started touching on is the growth of IoT, the growth of machine learning, the need for containerizing processes as well. I think those three trends we're seeing change massively. We've talked about things like AI as well. So with things like Bedrock, which is what AWS is now delivering to process this. And what that's going to deliver, I think, is faster search engines. I think the ability to search and check data quicker. I talked about data quality. I think that's going to become really important for machine learning and AI as we go forward. And anything that we can do to organize and prepare and index those data sets is going to massively help. But anything that improves quality, and quality sometimes gets missed in many of the things we do, I think is going to be a positive thing. And I think that's where we need to start using those tools more.
Yep, and I think I think Phil, you touched on these things, but serverless, technology, I think, is just going to keep taking over. I mean, it's much better. I've always compared it to owning a car versus, taking an Uber, right? You own a car, you're paying for it, whether that's parked or but you're in the car, right? That infrastructure is always running. Serverless, I can just hop in the car, I pay my money, and then I'm out of the way. So that's the way I think about it. But also edge, I think, is actually pretty interesting. What can you do to process more data, in an analytical workflow on said device? I mean, and whether that be your mobile device or wherever that data is coming from an IoT device. And I mean, just the fact that we're processing data for analytics on satellites is pretty nuts to to think about. But I think those two data trends, using all those pieces to make data more accessible faster is interesting too. So
definitely.
Fantastic. One last question, Matthew, for you here. We did have a request for how to access some of the CARTO algorithms for geospatial analysis. Can you maybe speak to how folks in the audience might be able to connect with you and learn more about that?
Yeah, so a lot of, effectively all our tools are packaged into what we call the analytics toolbox. So if you go to docs.carto.com, that'll give you an overview of what's available in each of the different data warehouses that we support. So you can actually install those. Every analytics toolbox has an open source component that you can use. So there's open functions that you can install and start using if you're in one of these data warehouses already. And then with a license, there's additional functionality that you can access from spatial data science, geocoding, processing of data with and then even all the way up to more advanced models that we've been starting to kind of create with the statistical models. So yeah, that's the best place to get started there. Go ahead and sign. There's a free trial on our website if you want to get started. I'll drop that plug in there, but that's the best way to get there as fast as possible.
All right, fantastic. Well, unfortunately, we've run out of our 40-minute time allotment for the day today, but please allow me to thank our speakers. We did, of course, hear from James Kobielus with TDWI, Matthew Forrest with CARTO, and Phil Cooper with AWS. Would also like to thank CARTO once again for sponsoring today's webinar. And please remember, we did record today's webinar, and we'll be emailing a link to an archived version of the presentation, which you can feel free to share with colleagues. And if you'd like a copy of today's presentation slides, you can locate the resource window to download the PDF. Finally, there's just a couple weeks left to join us at TDWI Nashville, which is taking place this month, May 14th through May 19th. At TDWI Nashville, you can learn from vetted instructors on topics including data governance, machine learning, data fabric, dashboards, and more. Save 30% off your first TDWI event with promo code FIRST30. That's FIRST30 by May 12th. You can view the agenda at tdwi.org/Nashville. We hope to see you there. Lastly, from all of us here, let me say thank you so much for attending. This does conclude today's event.